So Saxon always begins with review, and it happens that we are going to be reviewing some geometry definitions and formulas and concepts. So not on that page I just gave you, but still in your regular notebook. Let's do some vocabulary. First, a point is an exact location. We draw it with a dot, even though that dot is really too fat for a point. That's how we draw it. We label points with uppercase letters. So that's how I would draw and label point A. A curve is a series of connected points. So we can draw it without picking the pencil up from the paper. So maybe it looks like that. Maybe it is straight. If it is straight and goes forever without ending, we put an arrow on each end of it that we can draw because our papers don't go infinitely far. And it is a line. To name and label that line, we need at least 2 points on the line. So since I've already done an A, I will do B and C. That is the line that goes through points B and C. So I write those 2 letters and a line with an arrow on each end to say that it's a line. It goes forever in both directions. That is the same line as the straight line that goes through both C and B and keeps going forever both ways. If it does not keep going forever, if it stops, it has 2 ends, which we call endpoints. To name that line segment, we need to know the start and the stop. So 2 other letters. And this is the segment that goes from D, that starts at D and stops at E. So a straight line over it with no arrows. But that is the very same picture as if I start at E and go to D. If I want to kind of go halfway between a line and a line segment so that it has 1 endpoint, we call that a ray. So we must know the endpoint. So I'll call that F. I haven't used an F yet. And then I need 1 other point that is on that ray, G. So my notation would be the ray that starts at F, goes through G, and keeps on going. Now for this one, we do not write that as GF with the arrow going the other way. Even if I really drew an arrow that went to the left, the first letter must be the endpoint. The second one is some other point it goes through, no matter whether it points up, down, left, or right. It is also not the same as the ray that starts at G and goes to F, because that would start here at G, go through F, and keep on going to the left, and would not have this little part out here with the arrow on it. Does that make sense on the different notations there? One other definition for this slide: a plane is a 2-dimensional or flat surface. So I have the plane of the whiteboard. I have the plane of the smartboard. The floor is part of a plane. I say part of because really it goes forever in all directions. But I can't draw something infinite on a finite piece of paper, so we usually draw it with what looks like a parallelogram, but we understand that plane keeps on going forever and ever. And let me pause while you finish those definitions. So now let's talk about angles. And there are a couple of different ways that we can think about angles. We can think about them as 2 rays that share an endpoint or a vertex. So if this is A A is that vertex. That's where the angle bends. I would need to write its name. I would need a point on each of the other two sides. So that angle would be, here's the angle symbol, BAC. The vertex must be in the middle. It could also be angle CAB. So start at B, go to A, turn and go through C. Start at C, turn and go through A, or turn at A and then go through B. But it is not the same as angle ABC, because that would be an angle up here at the top. If I drew the third side of the triangle, it would be that top angle. Everybody okay there? Okay, this year we are also going to start thinking about angles as the amount of rotation. So if we take one starting ray, which starts at the origin 0, 0, and goes along the positive x-axis, that would be our starting ray. So the way that I've got it drawn there, it would be the bottom side of that angle that I've drawn. So we're going to take that ray and we're going to hold it still at the origin, and it's like a spinner in a board game, and you spin it and it stays fixed at that center and it moves a certain distance around the spinner. So that angle of rotation would be how far until the spinner stops, which would be up there. And that would be our terminal side. Any questions about that? Okay, I'm going to ask you a question now. Can you tell me some different types of angles? When we talk about angles, there are often some different ways that we classify angles. So, is it Alex? Thank you. What can you tell me? What are some? Or wow, you remembered all four. Usually I just get three of them. And you're exactly right. But Algebra 2, we're going to be a little bit more precise, and I'll explain why as we do that. So first, a right angle measures exactly 90 degrees, and we generally draw it with a little box in the corner. Obtuse angles, we are used to saying more than 90 degrees. And that's true, but we are now going to say between 90 and 180. Because if you think about that spinner, it can go around farther than 180. And so we are going to be just a little bit more specific this year about angles between 90 and 180. When we get to vectors, we will start talking about angles that are 470 degrees, that are 315 degrees, and things like that. And acute angles, we're used to saying less than 90, but we're now going to say between 0 and 90 degrees, because again, when we get to vectors, we're going to have negative degrees. And I love the way Alex also remembered straight angles measure exactly 180 degrees to make a straight line. When you finish this, have that formula page ready for our next ones when we go to the next slide. So on that formula page, formula number 1 from lesson A is vertical angles. And when my numbers get off later on, because it's not always the same year to year, let me know when I need to correct them as we're going through a lesson. Draw 2 straight lines that cross. And then vertical angles are the ones that are across from each other. So the ones labeled X and Y would be vertical angles and would have the same measure. The 2 that I didn't label, top and bottom, are also vertical angles and would also have the same measure. Complementary angles, who remembers about complementary angles? And I've got a picture clue up there for you. Is it Riley? Two angles that if you add them together, make 90 degrees. So draw your picture, label that this is a 90-degree angle, mark where the X and Y are, and then write down that X plus Y is 90 degrees. Anybody remember the similar word? Not complementary, not adding up to 90, but another one that we have. Anybody who hasn't volunteered yet who wants to try? Is it Elisha? Alicia, okay. Supplementary, do you remember what's true about those? They both add up to 180 degrees. So draw a straight line, and then somewhere in there, draw an angle coming up, and label one side X and one side Y, and write down that X plus Y is 180 degrees. Pretty much review so far, right? Except for the stuff about we're going to get to angles bigger than 180 and to negative degrees. What about my next definition here? It's often a new one when students come into this class. Does anybody know what we mean when we say reflex angles? That's what I thought. It's generally pretty new, and it looks something like this. If we have one angle, reflex angle is what it takes to make not 90 or 180, not the complement, not the supplement. What does it take to get all the way around to 360 and make a whole circle? So in this case, X plus Y would equal 360. And then I think we're ready to do some problems. And I'll try to talk as we do these, if it were a homework problem, what I would expect for you when showing your work, just to help make that clear as a reminder for everybody and information for anybody who happens to be new to our school this year. But I've still got a couple of people writing. Yes? You have more sheets of paper over there as you need them, depending on how big or small you write. Help yourself when you're almost to the end of a page, because everybody will finish at different times. Yes? Yes, except for ones that I say no calculator on. Maybe I've written on a homework set, no calculator, or the test will be split into two parts, calculator and no calculator. All right, let's do some problems. So now go back to your notebooks. If this is a homework set, you do not have to copy the picture because those boxes on homework sets aren't that big. Since this is in your notes, you don't have another place to look at it and make it make sense. So in your notes, go ahead and copy this picture down. Just know that on a homework set, you would not be doing that. When you have these kinds of geometry problems, I am going to expect an equation with a reason, and then whatever work is necessary to solve that. So it looks like we're getting close to having those pictures copied down and those things labeled. We've got the symbol for 90 degrees. We've got an X, a 30, a 40, and a Y. And then I want you to look at that and tell me how X is related to one of the numbers, so how we might be able to figure out what X is. Or tell me how Y is related to one of the numbers, so how might we be able to figure out what Y is? Anybody want to volunteer to get us started? Getting a couple of volunteers so far. Anybody who hasn't volunteered yet who wants to? Is it Jace? Excellent. X and 30 degrees are complementary. And it's not okay to just say X equals 60 complementary. I need the equation. What's the complementary relationship? Which is that X and 30 add up to 90 degrees. And that reason is complementary angles. So something like that. It's better to write out COMP because we're also going to have corresponding angles pretty soon and it gets confusing. Which one did you mean? If we don't write out a couple of extra letters, but you don't have to write out the whole long word every time. You may if you want to. Then solve it. You can show the minus 30, or this one's easy enough mental math. Everybody shout out for me, what is x? X is 60. There is already a degree sign in this picture, so we don't need a degree sign on it. And then if this is on a problem set, circle it with your pencil or box it to show that's your final answer. It makes checking go faster. Can anybody tell me a relationship that will let us figure out what y has to be equal to? Riley? Okay, because this is a straight line here. If we put the y and the 40 together, so we write that down, y plus 40 is 180. Supplementary angles, and everybody shout out, what is y? 140. Let's suppose that is an odd problem, so you're doing it as homework. I want you to turn to the back of the book while at home, before you come to class, and check your odd answers. If you get it wrong, figure out why, erase it and fix it. I'm not there looking over your shoulder. This is your way of learning. Fix it if it's an odd one. You've got time. Then take your correcting pen and say, I checked the back of the book, and this is what the back of the book said. So circle it a second time with your correcting pen. Evens, will do that same process. Circle it with your pencil at home so we can grade fast. You can quickly spot your final answer, but wait till you're in class and I give you the even answers to mark it with red. Questions on that? Just want to make sure you had enough to know what you needed to do tonight on homework. Okay, let's do another one. This time we need to solve for x and y and p. So there are going to be 3 parts to solve, 3 answers to circle, and there's more than one right way to do it. I'm looking for volunteers who can take one of the letters and relate it to a number. Don't put 2-letter things together at this point, or we won't be able to solve for it. Any others who have not answered yet? 2 times y for that whole angle. So who can relate something for me? Ellie, thank you. Excellent. So we can start out and write down that 110 and that whole 5x have to be equal to each other because they are vertical angles, and we don't have any other v's, so we can just do VA for vertical angles. Then we need to divide both sides by 5, show it if you need to, or do the mental math. And what does x have to be, everybody? 22. And we'll pretend this one is an even one, so we'll just circle it with a pencil and we would grade it tomorrow if it were on the problem set. Okay, now we know x. So we know we can take 5 times x, and we know 110. Who can take either the 110 or the 5x and relate it to one of the others, either the p or the 2y? Anybody else who hasn't answered yet? See a way that we can put 2 of those together. I'll eventually just start calling on people, but anybody else want to volunteer? All right, Alex. Okay, so we can say 110 plus p equals 180 because they are, the outside makes a straight angle, or the 2 angles are supplementary angles. Subtract 110 from both sides. Everybody shout out, what's p? Okay, so now we know p. We still need to get y. We have choices, but what do we want to put together that will let us figure out what y has to be? Blake, do you have an idea? Okay, so we could do 5x plus 2y is 180. How many want to do it that way? It's totally correct. How many have another way that you'd like to do it? And Jace, what do you think? That might be a little less math to have to do. Let's go with that one, but they're both totally correct. So we can say P, whoops, not plus, P equals 2y. So 2y is 70, and you said the reason was vertical angles, and everybody shout out what is y. All right, and we're okay on time. I have one more topic to talk about, which is absolute value. So still in our notes, not on our formula page. Anybody remember what we mean when we say absolute value? What, Jace? Okay, so it is the distance from zero. And if I drive north or I drive south for 3 miles, the odometer on my car just ticks off 3 miles. It doesn't go backwards if I go south and say it's a negative number. It just measures the distance positively. So absolute value of 0 is 0. It's no distance away from 0. If x is bigger than 0, that means x is a positive. The absolute value of a positive number is that positive number. If x is less than 0, it is a negative number. So the absolute value of a negative is drop the negative sign and just write down the positive number that is the opposite of that negative number. And last one for us to do here is one to simplify. So when you have this copied down, go ahead and let's simplify that, and then we'll see what answer or answers we come up with. So when we simplify this, we have this minus sign out in front here. Minus signs can never go through an absolute value bar. So we keep that opposite of, and then just whatever the absolute value of -4 is, which is a 4. So the opposite of 4, and then -2, and then plus, and the absolute value of -5 is the +5. Put those three together in whatever order you want. So for example, if you have a 6 and a -6 somewhere in it, maybe you put those together and make a 0 first. This one, I'm going to take the -4 and the -2 and make a -6, put it with a 5, and as you just said, I also get a -1. Does that much make sense to everyone? All right, so let's get started on your homework. And we only have time to do one. Let's do 24. So turn your paper over to the back, and let's take a look at number 24 and see what we can come up with. So plan your work, top to bottom, left to right. -5 minus the absolute value of -3 minus 4. Close the absolute value, minus 3 that gets squared, minus 3. And then we are going to go through and show our work. So you guys, like we did on the last one, go ahead and kind of start on that. And then we'll see if we can all come up with the same answer on that. So I'm going to keep that -5 the same, have my minus sign. Now I have a grouping symbol. What did you get for absolute value -3 minus 4, just for that little piece? What'd you get? So that's the absolute value of -7, which is how much? So you can write the absolute value of -7 if you want, or you can just go to a -7 on that. Your choice on which way makes the most sense, whichever way is going to let you get it correct for that step. Now we get here, This minus sign is not inside the parentheses. This is not -3 times -3. It is, let's subtract. What do we get? What do we get when we take 3 times 3? Everybody? So we're going to subtract 9 and then 3. So everything is a negative. And when you put all of those negatives together, what do you have, everybody? Excellent. And a box around it. Anybody else have questions?